Hello everyone, it's Red Saber here from Saber C++, and today we're creating a Pong game for the 8BitCade XL. If you don't know what that is or how to assemble it, check out the links in the description for a full playlist on how to assemble and program the 8BitCade XL with a variety of games. Remember, you can upload programs to the 8BitCade through the Arduino IDE just like any other board by connecting this micro USB on top to your computer. Let's get started. The first thing we'll need to do is include the Arduino library, which we can do by typing #include arduboy2.h. Then we'll need to create an arduboy2 object, which I'll call arduboy, to represent our 8BitCade console. I'd also like to create an integer called gameState, which I'll set to 0. We'll use this state to hold where we are in the game. So state 0 will be the title screen, state 1 will be the game screen, then we'll have states for the pause screen, the win screen, and the lose screen. In the setup function, I'll start by running the arduboy.begin function to initialize our 8BitCade console. Then I'll run the arduboy.setFramerate function and set the frame rate to 60. And I'll also run the arduboy.clear function to clear out anything that might have been on the Arduboy screen before we started playing the game. In the loop function, I'll check if not arduboy.nextFrame. So if the Arduboy isn't ready for the next frame, which will only happen 60 times per second, then we'll just go ahead and return. This will make sure that the Arduboy has enough time to run the calculations we need to run. Then we'll run the arduboy.clear function to clear out whatever was on the screen in the last frame, and the arduboy.pullButtons function, which will go through and check all of the buttons and determine if they're pressed or if they were just pressed. Then I'm going to create a switch statement, which will switch on the gameState variable, and will allow us to execute the proper code for each state. So in the 0 state, this will be our title screen. And in the 1 state, this will be the main game state. I'll do the same thing for all of the other states as well. We'll add code to these states in just a moment, but at the bottom, we also want to add the arduboy.display function, which will actually display whatever we do in these states to the screen so that the player can see it. Let's start by setting up the title state. So inside of this case 0 here, we'll go ahead and run the arduboy.setTextSize function, and we'll set the text size to 2, which will make the text 12 pixels wide and 16 pixels tall for each letter. Then we'll run the arduboy.print function and print out the word Pong. In between these two, however, we'll run the arduboy.setCursor function, and we'll set the cursor so that this text Pong will be centered on the x-axis and maybe a little above center on the y. So to center it on the x, we'll run the calculation of the width, which is 128, divided by 2, and then we need to subtract the width of 2 letters, which since each letter is 12, will be 12 times 2. On the y-axis, we'll want it to be 64, which is the height of the screen, divided by 2 once again, and we'll subtract 16. So it'll be a little above the center on the y-axis. Below this, we'll set the text size down to 1, and we'll print out, press A to start. And once again, in between these two lines, we'll set the cursor to the proper position. Now that we've set the text size to 1, the characters will only be 6 pixels wide. So since there are 16 characters in this text, we'll want to subtract 8, so that 8 of the characters are before the center, times 6. Then for the y-axis, we'll set it to 64 divided by 2, plus 2. So this will be a little below the center of the screen. The last thing we need to do is check if arduboy.justPressed A button in all caps. So this will check if the A button is down and if it wasn't down the last frame. So no matter how long the A button is pressed for, this justPressed function will only trigger once. And if the A button was just pressed, then what we want to do is set the game state to 1, which is the main game state, so that we shift from the title screen to the game screen. Let's upload our code and try it out. And now we have a nice title screen that tells us the game is Pong, and we can press A to start. And if we press A, it'll transition to a black screen. That's because we haven't actually set up the game loop yet. But it is now in the game state, so we can add all of that next. At the top, let's create a couple of variables for the paddle width and height. I'll create a variable called paddle width and set it to 4, and paddle height, which I'll set to 9. Of course, you can change these to be whatever you want. Then I'll create variables to hold the position of the player's paddle. The first we called player X, and I'll set it to 0, since the player will be on the left side of the screen. And second will be called player Y, and I'll set it to 32, which is half of the screen height, plus the paddle width divided by 2. In case 1, which is the game part, I'm going to call a function called gameplay, which I'll then create down below. This will be a void function, because it won't return anything, and we don't need to pass any parameters. Inside of this, I'll start by running the arduboy.fillRect function. And we'll fill a rectangle starting at the player X and player Y, and continuing for the paddle width and paddle height, in the color of white. Then I'll check if arduboy.pressed up button. Now since we used pressed, not just pressed, this will keep triggering as long as the up button is held down. So we'll be able to hold the up button to move the paddle up. And if the up button is pressed and the player Y is greater than 0, then we'll go ahead and subtract 1 from the player Y. Since the top of the screen is 0, going up means subtracting 1, and going down means adding 1. So then we'll check if arduboy.pressed, once again, down button, and the player Y is less than 63, then we'll increase the player Y by 1. However, since the paddle actually has some length to it, we'll need to make sure that none of the paddle goes off of the screen. So we won't just be checking if the player Y is less than 63, we'll be checking if the player Y plus the paddle height is less than 63, so that we stop when the top of the paddle hits the top of the screen and when the bottom of the paddle hits the bottom of the screen. Let's try it out. And as you can see, we still have our title screen, and if we press A to start the game, we have a paddle we can move up and down. Let's add a ball and an enemy paddle so we can actually play Pong. Let's create some variables to control the size, position, and movement of the ball. I'll start by creating a variable called ball X, which I'll set to 64, and another variable called ball Y, which will be 16. This will be the position of the ball, and I'll create an int called ball right, which will be 1 for how the ball is moving on the x-axis, and a variable called ball down, which will also be 1 for how the variable is moving on the y-axis. We'll also create an integer called ball size, which I'll set to 4 for now, that'll control the size of the ball in both dimensions, since this is square. Since the ball is always moving, this ball right variable will be 1 when it's going right, and -1 when it's going left. And the ball down variable will be 1 when it's going down, and -1 when it's going up. In the gameplay function, we'll start by running the arduboy.fillRect function to fill a rectangle at the ball x and ball y coordinates with the size of ball size in both dimensions, and once again with the color of white. Then at the bottom, we'll check if ball right is equal to 1, and if it is, then we'll increase the ball x by 1. Otherwise, if the ball right is equal to -1, then we'll decrease the ball x by 1. We'll do the same thing with the ball down. If the ball down is equal to 1, then we'll increase the ball y by 1. Because as you remember, 64 is at the bottom of the screen and 0 is at the top. And otherwise, if the ball down is equal to -1, then we'll decrease the ball y by 1. We also want the ball to bounce off the top and bottom of the screen. So we'll check if ball y, the top of the ball, is equal to 0, which is the top of the screen. If it is, then we'll just set ball down to 1. Otherwise, if ball y plus ball size, the bottom of the ball, is equal to 63, which is the bottom of the screen, then we'll set ball down to -1. That's all for the ball. We can use the same paddle width and paddle height for the computer, but we'll need to create integers for the computer x position, which we'll set to 127 minus the paddle width, so that the whole width of the paddle for the computer is on the screen, but it's on the right side of the screen, and an int called computer y, which we'll set to the same as the player y, 32 plus the paddle width divided by 2. Back down in the gameplay function, we'll fill a rect using the arduboy.fillRect function at the computer x and computer y, once again with the paddle width and paddle height, and once again with the color set to white. To control the computer's paddle, we'll want to check if the ball y is less than the computer y, and if it is, we'll decrease the computer y by 1. So if the ball is below the computer's paddle, it'll move down. Otherwise, if the ball y plus the ball size is greater than the computer y plus the paddle height, so if the bottom of the ball is past the bottom of the paddle, then we'll set the computer y to be increased by 1, which will move it lower. We also want the ball to bounce off of the paddles of both the player and the computer. So down here where we're doing the collisions for the top and bottom of the screen, let's add some code for that. So we'll check if the ball x is equal to the player x plus the paddle width. So if the ball would collide with the player's paddle on the x-axis, and if it would collide on the y-axis. So if the player y is less than the ball y plus the ball size, so if the top of the player paddle is higher than the bottom of the ball, and if the player y plus the paddle height is greater than ball y. So if the bottom of the player paddle is lower than the top of the ball. So this whole line checks if the ball and the paddle would hit on the x and some part of the ball would hit the paddle on the y. If that's true, then we'll set ball right to 1 to reflect the ball back at the computer. Then we'll do the same thing for the computer paddle, checking if ball x plus ball size, because remember this is on the right side of the screen, so we need to be checking the other side of the ball, is equal to the computer x. And if the computer y is less than ball y plus ball size, and the computer y plus the paddle height is greater than the ball y. And if this is the case, then we'll set the ball right to -1. Let's try it out. And some of you may have caught this mistake, but it looks like I forgot a y here and just typed computer plus equals 1, which obviously wouldn't work. So if we correct that mistake and try it again, it should work properly. Nice, it's really starting to look like Pong. We can hit the ball with our paddle, and it can bounce off of the computer's paddle and the top and bottom of the screen. Unfortunately, when we lose the ball, it doesn't come back, and the computer is impossibly good. Let's fix both of those and add some scoring and polish to the game. Before we do, if this video has been helpful to you so far, please give it a like so I can keep creating more. At the top, let's create our last few variables. An int called score to win, which will be the number of points the player or computer needs to win. I'll set that to 5. And an int for the player score and the computer score, which of course will both start out as 0. In the gameplay function, we'll start by, at the top, setting the text size to 1 so we can print out the score of the player and the computer. So for the player score, we'll set the cursor position to 20 on the X and 0 on the Y. So at the top of the screen and closer to the player side. Then we'll go ahead and print out the player's score. For the computer, we'll run the arduboy.setCursor function, and we'll set it to 101 on the X, and once again 0 on the Y. So it'll be at the top of the screen, closer to the computer. Then we'll print out the computer score. This will allow the player to see their score and the computer score during the game. Then we'll need to check when the ball goes off the screen to either side. So we'll check if the ball X is less than -10. So if it's gone off the screen to the left, the player's side, then we can increase the computer score, and we'll set the ball X to 93. So since the ball is going in the player's direction, putting it closer to the computer will give the player more time to react. Otherwise, if the ball X is greater than 138, so if it's gone off the screen to the right, then the player has scored a point, so the player score will increase by 1, and we'll set the ball X to 33. Since we want the computer to be beatable, let's make the computer have sort of limited vision. So we'll check if the ball X is greater than 105, and the computer will only react and move for the ball when the ball X is greater than 105. So when it's fairly close to the computer's paddle. Of course, you can change this. Setting this value lower would make it harder, and setting it higher would make it easier. So otherwise, if the ball isn't close enough for the computer to go for it, then we'll have the computer put its paddle back in the center of the screen so that it does have a decent chance of getting to it once the ball is close enough. So we'll check if the computer Y plus the paddle height divided by 2 is less than 32, then we'll increase the computer Y by 1. Otherwise, if the computer Y plus the paddle height divided by 2 is greater than 32, we'll decrease the computer Y by 1. So the computer's paddle will move towards the center when the ball is closer to the player's side, and when the ball gets close to the computer, it'll go for it. The last thing to do in the gameplay function is to check if someone has won. So down here at the bottom, after we've adjusted the score, we'll want to check if the player score is greater than or equal to the score to win. And if it is, then we want to change the game state to the win state, which was state 4. Otherwise, if the computer score is greater than or equal to the score to win, then we'll set the game state to 3, which is the losing state. Back in our switch statement, we'll need to show the player that they won or lost. So I'll copy all of this, including the A button stuff, from the title into the pause screen, the lose screen, and the win screen. So let's start with the pause screen. The first thing we need to do is change it from saying Pong to saying paused. Then we need to make this centered, so instead of having 2 characters before the center, we'll have 3 characters before the center. And then we'll change the press A to start to press A to resume, which will mean that we need to have 8.5 characters, since we have an odd number of characters here. If the A button was pressed, then we want to unpause the game, so we will be sending the game state back to 1. But we also want to be able to pause the game, so I'll copy this statement into the game statement and say if the A button is pressed during gameplay, then we'll set the game state to 2, so we can pause the game by pressing the A button, and unpause it by pressing the A button. For the lose state, we'll change it from Pong to saying you lost, which since that's 8 characters long, we want 4 characters before the center. And we'll say press A to restart, which will mean that we need to change this from 8 characters to 9 characters. If the player presses the A button in the lose state, then not only do we need to set the game state, but we also need to reset a few variables. So instead of simply doing that here, since we'll need to do the same thing in the win statement, I'll create a function called reset game all the way down at the bottom. And this will once again be a void function with no parameters. And inside of the reset game, we'll set the ball X to be 64, which is the center of the screen on the x-axis, minus the ball size divided by 2. So the ball will get put back in the exact center of the screen on the x-axis, and it'll stay at whatever y height, because that's fine. The player score and computer score both need to be set back to 0. And then we'll set the game state to 1, so that the game will start again. We could also set the game state to 0 if we wanted this to send us back to the title screen, but I think it's better to just put the player right back in the action. So for the win screen, we'll simply do the same thing. We'll do U1, and we'll add an exclamation point, which will make this once again be 4 characters long, and once again press A to restart, which will make this 9 characters long, and if the A button is pressed, we'll run the same reset game function as we did if the player lost. Now let's try it out one final time. And now our Pong game is done. There's this title screen, there's 2 scores shown up top, and you can either win or lose. Congratulations on creating your first game for the 8BitCade XL. Give yourself a pat on the back because this was no easy task. Be sure to check out the description for how to do more cool stuff with your 8BitCade XL, or visit my channel for lots of tutorials about other Arduino sensors and modules. Thanks for watching.